Hello ladies and gentlemen, what's up? It's Papa Bale. Welcome to the channel. Um, I'm calling this one the loop-de-loop. It's virtually two pulse motors running on two parallel 12-volt batteries. So they're spending very slowly because this is entirely a parallel circuit that kind of makes the shape of an eyeball socket. Just the socket. So it's like an oval, and there's a pulse motor on each point, and then in between each pulse motor, as we have here, is an SSG, but I've changed that now to a homemade switch. So now there's two homemade switches, and this is why I don't do schematics, because it just changes so often that I don't have enough materials to keep up with drawing a schematic for every change. But this was it yesterday, and I found that the SSG was spending too much. It was going too fast, and it was spending too much too quickly. So it wasn't good for what I was doing. That wasn't my goal, nor my objective, to go fast quickly. So I changed it up to the homemade switch, and now it's going like that. And it's a nice coil, 24 and 32 gauge, about 1,000 turns. It's about a 1.2 pound coil. And then this one over here, and this one's running rather smoothly. It's, maglev and everything. I know that they're spending, but are they generating as much as they're spending? That's what the goal is. And the numbers have been pretty stable all since I changed the switches. It was spending rather quickly on this one with the SSG, but I've changed it to the switch, and now it's spending a lot less. It's going a lot slower, but it's spending a lot less, and I believe it'll spend less ultimately than the transistor because it's not superconductive material. It's just steel and copper, and I believe it'll end up spending less than the transistor altogether. So yeah, that's awesome. I think it's great. I do ultimately think that the batteries will end up dead, but it's going to take a while. All right, peace out. Have a wonderful night. Please subscribe. Bye now. Woo!